All right, now we'll switch over to Zach here. So um, Zach's going to be talking about Git and GitHub for the last 30 minutes here.
Thank you, Adam. Can you all hear me fine?
Yep, and we can
Cool,
see your screen.
groovy. So I'll probably a wave, but I'll probably shut off my camera as well, just to kind of save resources. Um, so yeah, I'm gonna kind of just go over an introduction to GitHub, the actual web interface. I won't go really into the command line commands. If anybody would like to learn those, you can always reach out to me or Max, or we could always do a separate tutorial for that. So really the intro to GitHub is we're going to discuss what it is, talk about free and open source software, version control systems, and then the combination of all these together. As a side note too, if you are using Git, you typically want to use a downloader for Windows for it. And to kind of just talk more about GitHub, it's a web-based platform for the dissemination of free and open source software. A lot of the Project Pythia content that's all on GitHub. And GitHub provides pretty much version control, free and open source software, and other digital assets. It also provides forums. So if users want to discuss aspects of that project on GitHub, they can do that. There's also development operations for facilitating building and testing the software, a lot of the continuous integration stuff to make sure things are running correctly. Again, with the forms, there's bug reporting, tracking and labeling of certain pull requests and issues and those sort of things. GitHub allows you to also host the documentation for a lot of these projects. So, for example, the screen you're seeing even now, this page is being hosted on GitHub's IO pages. And GitHub also recently allows for these testing environments for these packages and projects too. There's really not a lot of experience needed for to be really proficient in version control. It really just starts with looking at the project, and it could always be something as simple as opening a first issue and being like, I noticed something is wrong with this package, or this would be neat to include in your package. And then usually the devs can kind of guide you to certain aspects of that. And and a lot of this is in the way GitHub allows you to interact with the developer, similar to like email or Slack, but it's just right on the project's page. You can kind of interact with these individuals. So free and open source software, FOSS is pretty much the term for the Python software ecosystem of that package just being open, free of charge, and it's most of the files are essentially publicly available. There are some or softwares that can be downloaded and free, but not necessarily open because they can be proprietary and those sort of things. There's even a hint to here, or kind of a side note, is that even Python language itself is free and open source. So on GitHub, it's hosted, I believe, as CPython. So all the Python development itself is also on GitHub. And the actual developer of Linux also worked on the development of Git. And so Git itself is essentially the command aspect of um, the version control system on like your terminal, and then GitHub is just kind of all these things put together. Um, the kind of the type of community input you can get for GitHub is the issues. So as people ask questions, bug reports, etc. Pull requests, which is when somebody wants to change code and put it into the main package, whether it be an enhancement, a bug fix, those sort of things, and as well as host the discussion. And there's also project tasks and kind of it would the comparison would be kind of like Trello, where you can have these tasks on GitHub to it and kind of assign things to other individuals to kind of work on these sort of things. So a successful open source project needs to be accessible via the web, and that way individuals can kind of communicate and work on the same project together. Think of it as like Google Docs or Google Slides, but with coding. And the Linux kernel and the Python language, these have kind of always been available using these remote access protocols such as FTP, HTTP, and SSH. And kind of over time, these tools have evolved to make it easier to work on these projects and kind of communicate and upload these things onto the web. And essentially, GitHub is just all these things combined. So version control, the web interface, the open source software, and and on GitHub, essentially, the project is hosted in a repo. So they're called GitHub code repositories, but the short term is usually individuals call a repo. And kind of an example is I'll pull up, this is the ARM Development's Aerosol Mentors Processing Routines repo. So this is just a general example of a repo. This is the group, and in this group there are multiple repositories. And on here, essentially you have all this code in these folders, and the pull requests and issues and a lot of these project tabs are ways to kind of communicate with the developers or work together on the project. Most projects typically then have a README as well to kind of explain things in the repo itself. And I'll kind of in the next 2 pages of this kind of walkthrough kind of show how to branch, fork, and all those sort of things. But that's just to kind of show you the base like view of the repo. GitHub is free in most aspects. So when you create an account, it's totally free. If you're working with open source repositories and those sort of things, there's usually no charge. I'm not entirely sure when pay gets involved. I think it's usually when you're private hosting projects and those sort of things. But if it's open source, there's no issues with that. A lot of the continuous integration stuff, so like the tests that run on your project, there are a lot of free softwares for that, such as like GitHub Actions. But that is kind of a side tangent of a thing that I could always explain another time. Kind of more advanced stuff, but pretty much just registering for a free GitHub account just requires an email, username, and password. And when you set this up, then eventually you have your own profile page. And then once you have that, you could essentially start working with these projects and can then start forking, which I'll explain in the next section, on kind of what you can kind of start doing once that's uh, pretty much done. But the summary is essentially GitHub serves as the web-based platform for these digital assets, these open source projects, this coding. It doesn't have to just be Python. There's R packages, there's Ruby, there's all kind of packages on GitHub. You can use, and essentially GitHub uses Git as the version control system. There's a lot of power in the GitHub web interface to do a lot of and has the tools to contribute to these packages. But Git itself also has more command line tools to help with kind of contributing. Um, but yeah, that's pretty much it for this section. If anybody has questions for the moment. If not, I could head to forking a repository. So what is forking? So forking is essentially, there is a project on GitHub and you want to contribute to that code, but you're not technically the owner of that repository. So what you would do is you would create a fork of that and it goes into your own namespace, your profile, and it's a copy of that package. You can then do changes to your version of that repo. And then if there are things you want to push back into the main repository, that's when a pull request happens, and then you can put those changes onto the main branch. But what I'll kind of show right now is kind of how you fork a repository using the Aerosol Mentors repo. And if I go back real quick, let's do a new tab. So here's the mentors processing routines. The owner's most likely Adam or Max. But if I want to contribute, what I can do is on the top right here, there's a fork button. So when I click fork, it's going to ask me where I want to put it. So I could put it under mine and also groups if I'm in control of some other groups. But I'm going to just put it under my own namespace, and I'm going to create a fork. So once I create the fork, it'll take a few seconds to pretty much copy that all over. I am now in my own forked version. So it says forked from ARM development, Aerosol mentors, processing routines. And it's saying the forked version is my username and then the routine. And so this is essentially my version, and I could do changes to this fork, and it will not affect the main repository. The only time it will then affect it is if I then do a pull request to that. But this is essentially just a quick and easy way to how to fork. And you could essentially do this to with any project that's on GitHub, and these would all be saved under your username. So if I go to my profile, go to repositories, essentially all of these repos are just forked versions of main repositories. And here's the Aerosol mentors, the new one. So essentially covered kind of the namespace you put it, and you get redirected, and then you have this copy. There's also cloning. So cloning essentially is you can take your forked version and copy it locally. That's a command line tool using git commands, but essentially you would copy this SSH command, and you would copy this in your terminal, and you would use the git command git clone, and this is how you would have it locally if you wanted this forked version on your local machine, if you wanted to work on it locally instead of remotely.
Say-
But Git, oh,
oh,
sorry.
sorry. There's a question here. Can you pull new updates from the main repo to update your fork?
Yes. So actually what I can do real quick is show that using Pythia as an example, because I actually have not updated it in a while. So this will kind of work out. So if I go to Pyart, for example, so you can do this both locally using commands and also remotely. So if I go to Pyart, for example, my forked version, it'll say I'm currently 4 commits behind uh, the main repo, the ARM DOE Pyart. And so what you can do is you can actually go over here to the right called fetch upstream. And what this is going to do is going to take the changes that have been done in the main repo and then bring them over to yours so that you're up to date with the main. This is useful, which I'll actually explain in the next section a little bit more too. But if I do fetch and merge, it's now going to say this branch is up to date with the ARM DOE Pyre main. So that's kind of how you do it from the web interface. So now I am completely matched up now with the main repo. So that's kind of how you do it through the interface. Um, yeah, so yeah, at this point you could edit files on GitHub itself. You can also edit them remotely or locally, I'm sorry, using Git, and then work with your forked copy to kind of do these things. And I'll kind of actually go more into the editing and the pull requests in the next section, but I'll stop here for a quick second, see if anybody has any other questions.
I don't see any questions at the moment. Just note that Max said that button's a lifesaver. So
Yeah, that
you,
it is. Yeah. Um, just as a little backstory of why that button's useful is, let's say you're editing a file, and before you edit and you don't update it, you go to change, let's say line 3, and you're changing some text in there. But somebody on the remote before that, they changed line 2. And what happens is when you go to do a pull request with that file, or you want to push that to GitHub, GitHub will kind of freak out. It'll be a conflict where it's pretty much essentially says, this file has changed here, but you're also changing it here. What is the true form of this file? And so there's conflict changing. So the best way to avoid this is to always make sure before you do changes, make sure you're up to date with the main repo, and then from there you kind of do your changes. There's also branches of those too, which will kind of help avoid these problems too, which I'll start going a little bit over into this section. So when you have a fork, uh, and even the main repo, you have a main branch. And for the main branch, kind of a good rule of thumb is don't ever change the main branch in your fork. And the reason for this is that way you always have kind of a backup if something goes wrong, something's changed incorrectly. That main branch is kind of the backup to always go back to make sure things are kind of fine. So what you usually want to do is create a separate branch of your fork. And I know it kind of sounds confusing. You have a fork of the main repo, then you have branches in your repo, but these are all just kind of subsections of it to kind of make sure um, you kind of back up. So I could actually go over this a little bit more in detail. So if I go back to the Aerosol mentors uh, main repository, and if I go actually to my forks, so if I go back here, those I already have it, go to mine. So here we have the main branch. There's also tags. Tags are usually used for releases. For those who are developing and kind of releasing the packages, you can tag a package to say between version 1.1 and 1.2. These are the changes that have happened. But if I go to um, kind of the branches, let me see if I remember correctly. Branch. Find or create a branch. So we'll call it CO, I believe. Branch CO from main. So now I'm in this CO branch that I've created based off the main. So it's identical to the main branch. This is all still under my fork of the main repo. And so I have this CO branch, and let's say I want to change something in this CO folder. So usually when you name a branch, you usually want it to represent what you're kind of changing. So if there was like a bug fix for, let's say, a plotting routine, I could call it the plotting bug fix branch or something of that nature. But in this case, I'm calling it CO because we're going to go into the CO folder. And so in here, we have these 3 folders here. So what I could do instead is I can say, I'm going to create a new file. And the name of the file could be foobar, which is a very common name used in coding. And I can say, hello, well, this is a tutorial.
Do you want to say
Foobar.
this .py? Yeah.
And so what this will do is create a Python file under the CO folder, and this is my new code, just print, hello, this is a fun tutorial. And so when you change files or you add new files and much more, you want to do a commit message. And what a commit message does is it's essentially a statement of what you have done. And so in this case, there's typically a header and then the description. So what I typically do is usually use an acronym to represent something. So in this case, I'm going to do add because I'm adding a new complete file. You can always do acronyms like docs if you're changing the documentation, style if you're changing like pep8, etc. So in this case, I'm going to just do add. I'm adding foobar.py. And this adds a hello print statement to CO subdirectory. And so what this is going to then add is a commit directly to the CEO or CO branch. So if I commit that new file, and if I then go back to the main page and go to CO, it is going to say now here, right here next to my username, I have added foobar.py. This green means I've added a line of code. And it is now saying the branch is one commit ahead of the ARM development Aerosol mentors processing routines main. So I have one more commit than the main repo does. So at this point, I've added code and I want to add it to the main repository. What you would then do is want to do a pull request. And so how you do this is you can use just compare and pull request on the top. And typically GitHub will update as soon as you update a commit to your branch, it will usually ask and bring this up and say, hey, you've done changes. Would you like to do a pull request and then try to push it to the main repository? So what you can do then is do compare and pull request. And so what it's doing right now is it's copying my commit message into here. If your pull request would say I've done multiple commit messages, so instead of just my one commit, I'm 3 commits ahead. You could also change this description to kind of represent the pull request as a whole, but seeing as I'm just doing one commit, I can just kind of represent it off of that. And so what this is going to do is then it's going to open a pull request on GitHub's on the ARM development Aerosol mentors main page. And then usually the main admins will be pinged and it'll say, hey, there's a pull request. We need you to review this. So when I do create pull request, so now I'm back on the ARM development Aerosol mentors page. And so under pull request, there is now one pull request open and it's the one that I'm adding. And essentially what it's saying is if I go to file changes, it's adding under CO foobar.py. And then this is the one commit. If there are multiple, it'd be a list. And then this essentially then has a conversation where the admins could come here, they could review the code, they can suggest changes. If there is a automatic test running, it's continuous integration. So if your code base will run these tests to make sure your additions to this main code base aren't breaking anything. It will run that and it'll have check marks to say, oh, you didn't break anything. Thank you. And then the reviewers can then take another or can continue looking at it and then they can accept it. So that's kind of essentially how to open a pull request. They would then review it. And then once they accept this pull request, your commit is now in the main repository. And what you then want to do is you would then go back to your fork and you would then, oh, go ahead, I'm sorry.
There's some questions here. Are you doing this pull request from the fork or from the branch in your fork? They don't understand why the need of creating the branch in the first place. So can you explain that a little more?
Yeah, so you're technically doing, I believe it's the PR from your fork of your branch of your fork. So you're essentially, in this example, I am pushing changes from the CO branch onto the main branch of the main repository. And the reason why I'm doing it from a branch and not main on my fork is let's say I do changes to the CO branch, right? Or sorry, let's say I do changes to the main branch, right? And then I go do a pull request and my code actually breaks things. It's bad code. I don't want to do that. Well, the issue is now my main branch has been updated with this bad code and I don't really have a reference kind of to go back to. You can technically go back to the main repos and reset your main branch back to that. But to kind of avoid that whole hassle, you essentially will create a branch of your changes. And if something goes wrong, I could just delete that branch and go back to the main branch of my fork, and then I can recreate a new branch with the fixes or the code that does work. So the main branch is essentially just always on your fork it's always like a backup if something goes wrong, I guess is the way to kind of put it. And just creating branches too is also useful if you're doing multiple development stages. So if you want to, let's say, for one branch, you're developing new plotting code, and you want to kind of separate that from, let's say, you're doing new correction code. You could kind of separate those two in two different branches, and if one goes wrong, you always go back to main. But you then have separate workflows to kind of avoid conflicts between the two. I don't know if that kind of helps explain it. It's yeah, it can kind of be confusing because you have the main repo, you have forks, you have branches, but it's essentially to kind of avoid error along this workflow and to also kind of separate the work you're doing kind of in its own namespaces, if that makes sense. Was there any other questions, Adam?
Not at the moment that I see. So,
Zach, if you want, I can share my screen. I could show the approval process, and then hit the merge button.
Stop sharing.
Just so everyone sees. So yeah, so this is looking at the pull request that Zach submitted. You can see his changes here. You can see that it passed all the checks. So if I actually wanted to go through and review this, I'd look at the files changed. I'd see, wow, that looks like a great piece of code. I like that. I can approve that. And that'll say that these changes have been approved. And then the final step would be merging that pull request. So now that that's merged, you'll see that this now shows that it's been merged into the main branch here under ARM development. And yeah, Zach, if you looked at his if we go to here, you'll see that his is now 2 commits behind, where now the main branch under ARM development is now ahead of his.
And then in this case would be then when I would, from my main branch, I would do the fetch upstream through the page to then make sure I'm matched up with the main repository again. So then now if I do another project on a new branch, I'm basing that off of the main repo and all of the current code in that to kind of avoid conflicts. But besides that, that's really it for that. Not sure if there's any more questions. Yeah, GitHub itself, it'll take some kind of getting used to, and then the git commands kind of add a lot. Good reference.
Yeah, I just put in the chat here too. So the Project Pythia tutorials, this is some content they put together. It's really nice. It includes sort of the whole workflow, and especially as like an asynchronous sort of reference. This is super helpful to go through and get more familiar with the terminology and such. So.